We are going to reverse engineer 3 components with 3 different levels of difficulty using nothing but a Sharpie, a paper, and a 2D scanner, of course, a caliper. I've reverse engineered hundreds of components this way throughout 20 years in my career. But this is the second level of difficulty. We are going to start with the easiest, then we get to this, and then we go to the nightmare where most engineers tap out. Place the component in a 2D scanner. Then measure at least one dimension, and also the thickness. Scan the component into the computer. Draw a reference sketch with the same dimension. Scale the image according to that reference sketch, and start drawing the geometry on the external and internal edges. After extruding it, we have it. This is me holding the component on the screen. You can see it's identical and it's almost done. So, one down, but this was the easiest. Each one of them gets trickier. Most people don't believe you can design this without having a 3D printer. So I wanted to make things interesting, and I went to 3D Labs here in Munich and talked to Fabian. Fabian is the head of the Fab Lab, and I made a bet with him. So I have made 3 components.
Yes.
And my idea is to reverse engineer them without measuring them. Are you willing to take that bet?
That you can do it?
Yes.
I believe in you.
but
I cannot bet against because I know that you're very talented and therefore
giving you good odds. If I can't, I give you a big shout out to Fab Lab and 3D Labs. And if I can, I just come here and make videos every once in a while.
I really believe in you, although I see that it's going to be complicated because, as you described,
yeah, they are curved.
They are curved,
yeah.
So it's not an easy reconstruction.
What about this one? How would you do this?
Okay, creating a tube, this is, I think, quite easy.
Sure.
But then I would even think that kind of form is a little more complex than creating it here. Therefore, I would guess this is more complex than this.
That's true.
So from complexity
point of view, you got the order right.
I would say this is the order.
Yeah, this is the order.
Easy, no-brainer.
True.
Complex because you have more forms in here and you have this curves. But here?
Yeah, this is the tricky one. So, what do you say? Let's take that friendly bet and see what happens.
Okay.
So, now this one is a little bit different. It's 3-dimensional and it doesn't have a flat opening, so you can't just put it on your 2D scanner and use the same technique, because this would come out like this. But we're still using a 2D scanner using an intermediary step. This is an iris mechanism. It works like a camera lens. So when you rotate them, these blades move inside these slots. And these slots are not straight, and nor can we measure them using a caliper. So here's what we do. We need a Sharpie and we need a paper. Cut a small portion of paper, hold it against the pattern. What we need is one fixed area. For example, this is a good area to mark. I'm gonna keep holding it so it doesn't move. Roughly like this. And then on the back, I'm going to press against the slots so they would reveal their position. Once they do, I'll try to mark their position. This is it, but that's not enough because we need to complete at least one segment of the pattern, something we can actually pattern around it. So this would be the minimum we can do. So we put this in the scanner. The outer edge of the Sharpie is important for us, and this proves it. The cleaner we do this, the easier our job at this point. So I'm gonna do this a lot cleaner and enter a new scan one more time. So this is the clean version. I'm gonna draw around the outer edges of the Sharpie as closely as I can because we don't have all the dimensions. I have only one reference dimension. Then we just create one of the holes, we pattern it 12 times, and we extrude it as thick as it should be. This would be the first component. I'm gonna repeat the same thing for this component as well. You do this and you get this, almost like a face. Again, we scan this, bring it into SolidWorks, draw around the edges, pattern it, and I'm going to assemble this to see if it works. Oh, okay, and apparently it's working, so I'm okay with this to leave it here and move on to the next component. Remember when I said most engineers tap out on the third one? This is why. This is cylindrical. It's got a path running around it. You can't stamp this onto a paper because the geometry wraps around.
That kind of form is a little more complex.
So here's what I do. I take a piece of paper, tape it to the side, press the paper around it, and while I wrap the paper around the geometry, I press my finger onto the path so I would leave a trace onto the paper. And then using this Sharpie, I would just mark that path and I end up with something like this. In SolidWorks, the wrap feature makes this ridiculously easy. One click and the flat pattern wraps around the cylinder. Now, if you want to learn SolidWorks properly, not just the basics and techniques like this with the support that comes with it, I've got a full course, link in the description. So here's the moment of truth. I've come to the 3D labs to see if the components I have sent them to print would actually work. I saw the quality of the print they did was absolutely amazing. The second and the third components were waiting for me on the desk, and after placing the blades inside the mechanism, I was a little bit worried if it's going to fit or function, but after wiggling the components a little bit, I realized it's functioning, and it was a very happy moment for me. So the second component was reverse engineered correctly. I wish I could say the same thing for the third component, but we will get to that soon. Let's go get Fabian.
So this is already the recreated one?
This is the original one I printed, and this is the reverse engineered according to that one, without measurement.
Okay,
yeah.
May I test?
Yeah, sure. So Fabian could work with this, and the second component was a success. But for the third component, I made a mistake. I mispositioned my image on the wrong place, and therefore the offset between the end of the cylinder and the end of the path ended up being wrong. So in this situation, I would usually reiterate and take it from there and get the job done. But since this was a bet, technically I lost. You actually won the bet. I came really close, but I made a very rookie mistake of not taking into account the length. Yeah, this one runs a little bit higher. I just did it a little bit shorter. Okay. That's the only mistake. But can you believe I did it with a 2D scanner, like a normal paper scanner?
With a paper scanner?
Yeah.
So you did that? Something like that?
You cannot do that on a scanner. Fabian asked me if I rolled the cylinder on the 2D scanner and scanned the circumference around it. But I explained to him the method that now we know, using the paper to do the job on the cylinder.
Okay.
Yeah.
Okay. Smart. Good.
Yeah.
Good idea.
Into the video.
Okay, excellent.
Good bet.
Good bet. But anyway, I'm really impressed because I like those smart methods to solve problems.
Although he was really impressed, since technically I lost the bet, I asked him a few questions about what 3D Labs does to give him this shout out.
The 3D Experience Lab is our initiative at System to nurture innovation. Yeah, it's called 3D Experience Lab. So a lab, we really consider ourselves as a laboratory for innovation. And we do we have two fields of activity. One is about startups, so we're supporting startups with dedicated programs. And the other one is we develop our own projects, we trigger innovation, and we bring people together. So next time someone tells you that you need a 3D scanner to capture complex geometry, remember this. The best measurement is sometimes no measurement at all. If you like this video, you're gonna love this video on the left. Is it left? No, it's right.